Alright, so we spent a few days on ionic bonding and ionic formulas and naming, and now we're going to jump over to covalent bonding. So we're going to start these notes with our first question: what is a covalent bond? Alright, so as we've talked about before, right after the You Light Up My Life lab, that light bulb lab that we did, we said that covalent bonds are a bond between two or more nonmetal atoms. So the key word there is nonmetal. So remember when we were talking about ionic bonds, we said that nonmetal atoms are going to gain electrons. So in a sense, we can think about these nonmetal atoms wanting to gain electrons, so they can't gain each other, so they compromise by sharing. So it's a sharing of electrons between two or more nonmetal atoms. So another way we can explain a covalent bond is that it's a link between two atoms when they share their valence electrons. So it's unlike ionic bonds. Ionic bonds are actually giving up or taking away electrons. In covalent bonds, we are sharing the valence electrons. So down here at the bottom of the screen, you can see hydrogen. Hydrogen has one valence electron, and so to make a bond and fill its shell, two hydrogens can share each of these two electrons here, right there in the middle, and that will fill up that first shell and make them nice and happy. All right, last but not least, a covalent bond results in the formation of a molecule. A molecule is like a compound, except we usually say molecule when we're talking about a compound that has two or more non-metal atoms bound together. So molecules are usually referred to when we're talking about covalent bonds, and compounds are usually referred to when we're talking about ionic bonds. However, they do mean the same thing: two or more atoms bound together as one unit. All right, the second question we're going to deal with in these notes is: what is a molecular formula? All right, a molecular formula is a shorthand way to represent a molecule. So basically, it's how we write out, for example, water. Water is a molecule. It's made out of hydrogen and oxygen, which are two nonmetal atoms together. So a molecular formula is how we write out, the H2O. It provides the number and kind of each atom, and basically, again, it's a synonym for chemical formula. So we've always said, chemical formula for salt is NaCl. Molecular formula is the exact same thing. It's the synonym for molecular or chemical formulas. So they both mean the same thing. So let's take a look at an example here. CO2 is an example of a molecular formula for carbon dioxide. And again, it's going to tell you the number and the kind of each atom. So here we have a C, right? And there's an invisible one right here. We can think about it. So it's one atom of carbon in this molecular formula. Here we have oxygen, right? And the 2 means that there are 2 atoms of oxygen, right? So 2 atoms of oxygen in this molecular formula. So that's basically a molecular formula. It is the exact same thing as a chemical formula. Our third question is: what is a structural formula? So there's a lot of formulas here that you need to kind of keep in check. We have chemical formula and molecular formula, which basically mean the same thing. That's going to be your NaCl, your H2O, like the symbols that we use for compounds and molecules. Now the structural formula is a little different. It's actually how we draw out the molecule to show how the atoms are connected. So here we have a drawing to show exactly how those atoms in a molecule are connected. So let's take a look at some examples. So for example, if we had the molecular formula NH3, a structural formula is actually NH3 drawn out like this. It uses letters and basically dashes to represent the bonds in a molecule. So another one would be CO2. Okay, so in CO2, it's carbon double bonded to two oxygens. All right, and then we'll just do one more. How about water, H2O? So again, the H2O is a molecular formula for water, and the structural formula for water is actually how it's drawn out. So we see that there's oxygen that is single bonded to two hydrogen atoms. So these drawings right here, these drawings are what we call structural formulas. Now tomorrow, what you guys are going to do is you're going to use structural formulas to show how atoms are connected in different covalent molecules. So the next question we're going to deal with is a simple rule to help you figure out the covalent bonding rules for different atoms. So our fourth question is, what is the honk 1, 2, 3, 4 rule? All right, so this honk 1, 2, 3, 4 rule is basically a covalent bonding rule. It helps you figure out how many bonds different nonmetal atoms are going to make with each other, because it can vary, depending on if there's single bonds, if there's double bonds or triple bonds in a molecule. So we have to keep that into account. So this is a simple rule to help us figure out exactly how many bonds hydrogen, oxygen, nitrogen, and carbon make, which are the four most common elements in molecules. All right, so here's what it means. H, from our honk, can make one bond. That means when we see hydrogen in a structural formula, it will always be represented with an H and only one line coming out from H, because he can only make one bond. So remember, the lines represent bonds in structural formulas. Now the O, in honk, makes two bonds. So that means oxygen can make two bonds. So he will always have two lines coming out from oxygen, whether it's single bonds on either side, or you could always also have oxygen making a double bond with somebody. Now, the N is nitrogen, and he makes three bonds. So again, nitrogen will always have three sticks coming out from him when he is in a structural formula. So again, we can have three single bonds, or we can have a double bond and a single bond, or we can even make a triple bond with nitrogen. And then last but not least, carbon makes four bonds, and he's the most versatile element known to man. So carbon can make four bonds, so he will always have four sticks coming out of him in a structural formula. So we can have four single bonds. He could make two double bonds like we saw earlier in CO2. He could make a triple bond and a single bond. He could make a double bond and two single bonds. The variety is there for carbon. So he's the most versatile. But that's what the honk 1, 2, 3, 4 rule means. Okay, it's the H goes with one, the oxygen makes two bonds, nitrogen makes three bonds, and carbon makes four bonds. Now you're going to want to remember this rule for tomorrow when you are creating the structural formulas for some molecules. So you have to keep this in mind, because you're going to never want hydrogen with two sticks coming out of it, because that's not possible. Or for example, nitrogen can't just have one stick coming from it. He has to have three bonds. So you need to keep this rule in mind tomorrow when we're doing the structural formulas for certain molecules. All right, we are almost done with these notes. We have two more questions. This next question I've actually already answered in the last slide. This question is, can an atom have more than one bond with another atom? And the answer is yes. All right, molecules, covalent molecules can form double bonds, which is two pairs of electrons. So that means four total electrons are shared between two atoms. Each atom is sharing two of its electrons. So when we're looking at structural formulas, oxygen, nitrogen, and carbon are able to make double bonds. But remember, hydrogen cannot because he can only have one bond anyway, so he cannot make double bonds. And then we can also have some molecules making triple bonds, which is 3 pairs of electrons, so 6 total electrons. That means 3 from each atom is being shared between the 2 atoms. And so in the honk 1, 2, 3, 4 rule, only nitrogen and carbon are able to make triple bonds. Now if we take a look here at our drawings, this oxygen, O2, okay, is what this molecule is. Since we hooked up 2 oxygens together, we can see that each oxygen atom is sharing 2 of its electrons, okay, to make a double bond right here. So we've got 2 orange ones from the orange oxygen and 2 green ones from the green oxygen. It's 4 electrons total being shared in this double bond. Now on the other side, okay, we have nitrogen. Okay, nitrogen gas, or N2, is a molecule in which there is a triple bond. And we can see here that each nitrogen atom is sharing 3 electrons each, okay, for a total of 6 electrons being shared in triple bond. Now, the question of the day is, can a quadruple bond exist? And unfortunately, no, quadruple bonds cannot exist. All right, so here we go again. A quadruple bond is not possible because it's too straining for the atom. Okay, so for example, carbon trying to push all of its electrons on one side of himself is just way too straining for him. It's too difficult. And plus, remember, electrons are negatively charged, so they are going to have high repulsion from each other. So it's kind of, even lucky that we get a triple bond out of them because they're going to want to stay away from each other. So that quadruple bond is just way too much repulsion and way too straining for a carbon atom to do. So quadruple bonds are not possible. All right, here we're on to our very last question. What are molecular isomers? All right, so isomers are a little complicated for some students to understand. Basically, sometimes we can have molecules that have the same molecular formula, but when we actually draw them out, there are different ways that we can draw them out. So they're going to have different structural formulas. And so they're going to have different properties. And so an isomer is 2 or more compounds that have the same molecular formula but different structural formulas. So let me show you an example. So we're going to take the example of the molecular formula C4H8O2. Okay, so this is molecular formula C4H8O2. Now, when we draw this out, we are basically, first we're always going to start with our carbons because they're the most versatile. So there are many ways that we can draw this out. We can draw all the carbons together in one long chain. Okay, like perhaps some of it that you'll do tomorrow in class. And then we can put an oxygen at the end. Okay, and we can put our 8 hydrogens around. 1, 2, 3, 4, 5, 6, 7. What are we going to do? Okay, 8. Okay, and then we're going to add another oxygen here, double bonded to the carbon. Okay, to finish off our O2 and to make sure, right, that this carbon here has 4 bonds. So each of the carbons, if you look, has 4 bonds. Every hydrogen has 1 bond, and every oxygen has 2 bonds. Okay, so we've got a legit structural formula here, but this is only one way that we can draw out C4H8O2. Here is a different way. Instead of putting all the carbons together and the oxygen at the end, what if we sandwich that oxygen. What if we do carbon, carbon, oxygen, carbon, carbon? Okay, and we can put, a double bond oxygen somewhere else and then fill in with all of our hydrogens like this, and we get a completely different molecule because now we have this oxygen here in the middle of the compound rather than at the end. And so it makes it a different molecule, although it has the same number of carbons, hydrogens, and oxygens. It's a different structure, so it's going to have different properties. So these two guys are what we call isomers of each other. Okay, so when we are drawing out the different structural formulas for different molecular formulas tomorrow in class, some of them will have a number of ways you can draw them out. And if you figure out different ways to draw them out, you have basically drawn what are called isomers. All right, so tomorrow we're going to put all of this stuff together in drawing out going from simple molecular or structural formulas all the way to more complex ones like you see here. So we'll see you tomorrow for the activity.